Hi, today I'd like to talk about movement at constant speed around a circle. And what I have here is a circle depicted with a radius of r. Okay, and at this position here, I've got an object that's moving around at a constant velocity or at a constant speed v. And theta is going to be the angle between the horizontal and the angle from the origin to the position on the radius where the object is currently located. Vertical will represent the y-axis and the horizontal will represent the x-axis. Now the first thing that I want to talk about is the speed v. Okay, the speed, which I'm going to call v, is equal to the radius times a change in the angular displacement over a change in time. And mind you, if it's going around the circle faster, or basically taking half as long to go around the circle of the same radius, then it's going twice as fast. And similarly, if it's taking the same amount of time to go around the circle, but the circle is twice as big, then it'll also be going twice as fast. And that's why we have r d theta over dt. Okay, so now, first, before we look at this, we're going to look at the position, okay? So, position along the x-coordinate, we're going to call that x is equal to r times cosine of theta, and the vertical component of the position, which is y, is going to be equal to r sine theta. And so what I'm going to do, I'm going to start with x, and I'm going to find the velocity. So what I'm going to do, I'm going to differentiate it with respect to time. Okay, so v sub x, which is a velocity or the speed in the x direction, is going to be dx over dt, which is going to be, in this case, dr over dt cosine theta minus r sine theta d theta over dt. But as we said here, it's going to be constant radius since it's a circle. So the change in radius or the change in time, that's 0. Okay? And so now velocity in the x direction is just going to be minus r sine theta times d theta over dt. Okay, so now to find the acceleration in the x direction is going to be now d squared x over dt squared. I'm basically taking this and differentiating it again with respect to time, okay, which is also that. Okay, so in this case it's going to be minus dr over dt sine theta d theta over dt, and in this case minus r cosine theta d theta over dt times d theta over dt, okay, because I'm differentiating with respect to theta over time. Okay, so d theta over dt parentheses squared, and in this particular case again minus r sine theta d squared theta over dt squared. Well, in this case, as I said again, this is a constant radius circle, so the rate of change of the radius over time, that's going to be 0. Similarly, also, because we're traveling constant speed, the angular acceleration is going to be 0. So now what we have left now is minus r cosine theta d theta over dt squared. And that's basically the x component of the acceleration. Okay, so now let's look at the y components. Okay, I'm going to differentiate that with respect to time. So v sub y, which is the velocity in the y direction, is equal to dy over dt, and that is going to be equal to dr over dt times sine of theta, in this case, okay, plus r cosine theta d theta over dt. And as I said before, the rate of change of the radius with respect to time is 0, since we're looking at a constant radius. So it's going to be basically equal to r cosine theta d theta over dt. Okay, so now let's find the acceleration in the y direction. A sub y is going to be equal to now d squared y over dt squared, which is going to be equal to, in this case, dr over dt cosine theta d theta over dt, and in this case minus r sine theta d theta over dt times d theta over dt, so that's d theta over dt parentheses squared, and in this case again plus r cosine theta d squared theta over dt squared. And again, angular acceleration is 0, so that goes to 0. And rate of change of the radius with respect to time, that also goes to 0. And so what we have now, the acceleration in y direction is going to be equal to minus, okay, r sine theta d theta over dt parentheses squared. So now what we want to look at now is that if I want to find the total acceleration is going to be, I'm going to use a Pythagorean theorem, and saying it's going to be ax squared plus ay squared, and takes the square root of that, and we'll get the acceleration. So in this case now, okay, total acceleration is going to be the square root of, okay, in this case the negative sign is going to disappear, so I'm going to get r squared cosine squared theta d theta over dt to the fourth, okay, and in this case again the negative is going to disappear. It's going to be plus, okay, r squared, okay, sine squared theta d theta over dt to the fourth. And so what we got now is that acceleration A, I'm going to factor out the r squared and the d theta over dt to the fourth, and I'm just going to have r d theta over dt squared times, okay, parentheses, I'm sorry, not parentheses, but radical cosine squared theta plus sine squared theta, which we all know that's equal to 1. And so in this case now, the acceleration is equal to r d theta over dt squared. Okay, so now its acceleration is equal to the radius times the angular velocity squared. Okay, so now I can do this and multiply by r divided by r, so it's going to be r squared over r. Well, r squared d theta over dt parentheses squared, that's the velocity squared. So acceleration is equal to the velocity squared over r. And what we have here is the formula for the centripetal acceleration. Anyway, that is all I have for now. I hope you find it informative, and I'd like to thank you very much for watching.